My name's Robin. I presented on the first day, on Monday, and I guess compared with today, that was quite a kind of talky, more philosophical presentation in which I said that I think geocomputation should be practical, it should be reproducible, and it should be doing something that's socially useful. I also asked people to go outside their comfort zone, so try and explore, try and look at a problem that maybe they don't look at in their everyday work life. So this is a great opportunity just to experiment with new software like GeoPat. I imagine very few people had used GeoPat, but there's all these amazing open source tools like GeoPat that we can use. So this this session is more of a workshop, more of a practical workshop than me talking. So I'm definitely aiming to spend less time talking and more time programming. So I've got my little RStudio console and source editor up there as a signal that this is what I'm expecting people to have in front of them, not Facebook, hopefully. And the other thing to say before I start, this idea of source code. So I try to provide a link to the source code in most of my material because, as Jakub said, scientific reproducibility is really important. And if other people can reproduce your code, then that's a good thing. So the first thing to say, these slides, if you want to access them, we've created a little website called geocompa.github.io. And this is like a support website for the book that creates additional materials. So we've got various questions and answers. And we also have presentations. So if you want to find my presentations or maybe skip forward or skip backwards, these are the slides that I'm presenting on, spatial data in the tidyverse. So that's something about reproducibility. The other thing to say, which I have already mentioned, is that we're presenting this in the context of a team effort. And I think often, I know a lot of people in here are PhD students, and that can be quite a lonely process where you're just working on your own. And I remember when I did my PhD, I felt like I was down a coal mine just trying to hack against this brick wall of knowledge. But it's actually one of the most satisfying things about research is working with other people. So this is really a collaborative effort, and a lot of the work behind it comes from Jakub and Yanis as well. So this is really presenting the result of a team effort. So I've already talked about who we are. Jakub has mentioned the visualization competition, and not everyone wants to do spatial prediction. So if spatial prediction is not your thing, or the 9 million points that are in there are crashing your computer and you want to get a bit creative, if you can come up with something better than an R in the globe as an idea, it can just be an idea drawn down, then that's fine. And we've got, it's not $150 hard cash, unfortunately. It is a voucher, so you're going to have to spend it on books. But CRC Press has loads of geospatial books, including ones on geographic visualization that's recently been released. So that's a little bit of context. I'm not going to read through this long texty slide, but basically it's just about what we mean by the tidyverse. So the whole thing is called spatial data in the tidyverse. And as has already been mentioned quite prominently yesterday, there is a meta package called the tidyverse, and the aim of the tidyverse is to work with tidy data. And we just mean using functions such as the pipe operator and filter, which is an alternative to base R subsetting, and let's see how well this works with spatial data. There's one other thing that I want to show people which surprised me. So somewhere in here there's a poll. I think this isn't up to date. 37 votes. So yesterday I just wanted to know what people are interested in studying. So I was kind of expecting that building on Ed's example of breweries would be a really useful example data set. But I'm personally very interested in sea level rise, so I provided these 3 options, and to my surprise, loads of people are interested in sea level rise. So in a way that's good, because this is a new area of research for me. I'm not a sea level rise researcher, but I want to know what's possible. And this is a great way to learn. When you try a new problem, then that's a good chance to improve your skills. Could I just I know at least one person in this room has done flooding and sea level rise research. Has anyone specifically studied sea level rise? Okay, so that's fine. But I think, could you put your hand up if you think you've got the skills that might help sea level rise researchers understand the spatial distribution of sea level rise, the impacts? I think everyone in this room's got some skills that could help with that. And by tackling a new problem and going into an area where you're not comfortable, I think that's a great opportunity for learning. So anyway, that's why I should say these 3 things are not mutually exclusive. So there's going to be exercises that can continue with the breweries example, where I'm asking some questions that you can use these tidyverse functions to analyze. But there's also a more advanced sea level rise question in there. So that's good. Okay, back to the slides. I'm not going to do too much context because we covered it yesterday, but there's one thing to say about tidy data. It does have a formal definition that is described in an article by Hadley Wickham, where he's just saying there's many forms of data, but tidy tools are ones in which it has a specific format. So each variable is a column, so time or even location. Each observation is a row. So imagine you've got countries, each new country is a row, and each attribute of that country is an observation. Interestingly, tidy data encourages very long tables. So if you've got, for example, a data set where you've got multiple time points for the same country, so let's imagine we've got Czech Republic in 2000, Czech Republic in 2005, Czech Republic in 2010, can someone tell me how this would be represented in tidy data under this definition? Yeah?
So Czech Republic is the row.
Yeah.
The column would be one type of attribute, like temperature.
The attribute is time. So
it would have one observation per row. That's the
yeah.
raw tidy data, and you would have for each timestamp a new observation for the Czech Republic in a new row.
Yeah, that's exactly right. So what he said was it basically duplicates the word the word Czech Republic for every time you've got that timestamp. So tidy data encourages long form, and the wide form of data, which I wouldn't call messy data, it's just another representation, would have that each timestamp would be a new column. So basically, tidy data is having long tables with few columns. And you can have multiple tables and you can flick between them. So historically, spatial R packages, well, I wouldn't say they weren't compatible, they just evolved as separate ecosystems. And I'm going to demonstrate that in a bit. So this is basically a graphical representation of the tidyverse. There are a whole load of packages, such as Magrita, what else is on there? Lubridate, tidyr, dplyr is one of the central packages of the tidyverse, and they all fit together. So you won't have any name clashes, and they're designed to work with the same type of data. So basically, there's some integration. And Edza Pobesma is not here today, but he said that the reason that this has been possible is most of these packages are developed by the same organization, which is RStudio. So this is what's made it possible, and they fit together fairly well. So SF is a relatively recent package, which we know, and combining them is the topic of this workshop, and we're going to do it within the context of geocomputation with R. So this is just showing rabbit out of a hat. Here's one we built earlier. We've written a book that kind of tries to be at the interface of this tidyverse world. We use a lot of tidyverse syntax and a lot of tidyverse functions, but we also try to use the cutting edge spatial data as well. So in terms of reproducibility and collaboration, I've already covered where you can find the slides. I've already shown where you can find the source code. And I think it's beneficial for us to kind of do this as we're getting up to speed, because we start with very simple examples if everyone is doing this at the same time. So, and I'm also going to show people, going back to Tom's talk about how do you start a project, so a crash course. Normally the first thing to do during a project is to create a new RStudio project, if you use RStudio, or at least create a folder where everything associated with that project can be. So you can do that by creating a directory on your computer, but you can also just download all of the stuff associated with it. So if I'm saying that the source code is, can be found here, I'm just going to go to this GitHub repo, which is geocompa geostats19, and I'm going to download this package and this directory. So it's 12 megabytes. I don't know how good the internet is here, but it seems to have downloaded. And I can extract this, and let's say I want to put it in my desktop. You don't have to do this, so all of the stuff in here is reproducible, and this actually doesn't even contain all of the data, but I'm just demonstrating a way to start out on a project if you want to have the same project files that I've got. So I can show the files here, and I've got this new folder called Geostats 18 master. And the way, this is just recapping what was taught previously. The way that you initiate new projects in RStudio is you can just say open existing project. So if you save your work as a project, it encourages people to open it in the right working directory. So commonly, a common problem with doing any kind of programming is working directories that you may not know exactly where you are. So I'm going to open this new one, which is in here, Geostats master, and in fact, there's not a project file, so we can just go new project, don't need to save this one, and hopefully you've already got a directory for this, or you can create a new directory, and in this case, I'm going to open this. So that way you've got all of the code that I have, and it makes it very easy for you to build on what I've already done, is the idea. And I've put some code in here, which at the moment doesn't really have anything. So if you want to, this is a place where you can dump code. So far, in terms of the live demo, all I want you to do is to create a project file. It doesn't have to be the same one. I think there's advantages if you download the same repo which I've done, which is this one called Geostats 18. But basically, the idea is to have an RStudio project open. And that's useful because I'll come on to why that's useful in the slides. So, Okay, so that's the first point where everyone is. And usually in a project, the first thing you do is you have dependencies. So you're going to want to load some libraries for handling data. If we want to work with raster data, which you probably do, if you're doing sea-level research, you would do something like library raster, and that also pulls in the SP library. So that's a dependency of raster. We're also going to load in the SF package, which is for vector data. And then finally, because we're doing the tidyverse, we'll load that. So if you don't have any of those packages available, then you will have to go away and install them. And one thing that I wanted to show that I think is quite important about the tidyverse and about namespaces in general is that when you load the tidyverse, you should get some output. So the tidyverse is a bit naughty in a way because it uses function names that are already in base R. So when you load it, it basically overrides base R's package function names for doing things. And it's also overridden some raster names for doing things. So this has caused me problems in the past that I'm trying to select something, and if I've loaded raster after I've loaded the tidyverse, this can create problems. So just be aware of this. And something else that's important when you're using the tidyverse, if tidyverse has conflicted or has masked another function, the way that you can get back to your raster function name is just by typing raster, and then in this case you can say select. So that's how you would refer to raster functions. And to be safe, if you're using the tidyverse and raster packages at the same time, it's probably safer to refer explicitly to dplyr select or raster select. So that's something to be aware of. So as you can see, tidyverse, because it's a meta package, it's got loads and loads of function names, and it's going to load them all in. What's good is it tells you that which ones are breaking, and it tells you how to refer to that, but that can really cause problems. So the original title for this workshop was Spatial Data and the Tidyverse Potential and Pitfall. Just as you get started, that's the first pitfall that you can fall into that I can make you aware of, that it's going to mask other function names. Okay, so a very small little detour as well. I think it's important to be aware in terms of reproducibility and seeing where you are. Everyone should have their RStudio project open, and you can list the files in there with a function called list files. So I'm going to execute that, and I can see that there's various things in this project directory that either I've created. I should say that probably a more common way of doing this in terms of the history of computing is to use a system command, and you can also call system commands from inside RStudio. So the other way of doing this, and this should work on all the computers here, you can just go system ls, and you can see the output looks slightly different, but the result is the same. So even on Windows, I believe, you can just say list the files in there. That's a very simple system command, but there are many times when having access to the system is a good thing. And if you want to make your research more reproducible and more kind of computational, using the system is good. Something that is a bit of an RStudio trick is that you can even do stuff like writing code for the system directly. So if I say, this is a shell command, normally I would have to call ls inside quotes, but it's also possible to execute that in the system without calling the system function. So can anyone tell me how to do this? Does anyone use this way of working in RStudio? Any ideas? So as with many things in RStudio, there's a shortcut for it. So what you can do now, and this is a recent development, it's been available for about 1 year. You can press Control-Alt-Enter, and what's happened here is that I've switched from the R console into a terminal, and because I pressed Control-Alt and Enter, it knew that it didn't want to dispatch it to the R terminal or the R console. It wanted to dispatch it there. So you can do quite a lot of stuff in here. So another function is ls, and give me more details of the things in there. So these are just some arguments in bash. And again, I'm pressing Control-Alt-Enter. And as Jakub told us on Monday, all of this is somewhere buried in the shortcut commands for RStudio. So my point is not to delay us getting our hands dirty and reading in some sea level rise data. My point is to describe some things that may be useful to you. And the reason why I'm describing all this is that I used this commands line approach to create a short link that should hopefully make life easier in terms of actually downloading the data. So I deliberately did not put all of the big data sets into the GitHub repo. Generally, it's a good idea to keep code and data separate. And a good way of doing this in GitHub is via releases. So you can release code and put it into somewhere on your GitHub repo that's called the releases file. And that way you won't download all of that data every time someone clones your repo. If that didn't really make sense, don't worry. The main point is that we've got a location online to ensure that this is a reproducible analysis where you can download the data from. So I'm going to do this in my new session where I don't have any data at present. So I think everyone who wants to do the practical side of this can do this at the same time as me, and I just hope that the internet can download it. So trying to remember the name here of the file, download.file is downloading. So if you're using data from an external source and you want to make it reproducible, probably a good place to start is by downloading the data. So I'm going to type in https git.io, and then I've called it spatial tidyverse. And I made a typo, so there's no E on tidyverse. Spatial tidyverse. Okay, so I shortened the URL because it would have been really long before. That looks okay to me, so hopefully I'm going to execute this and it's going to download some data. No, because I haven't given a dest file thing. So again, I need to give it another command. By the way, this dest file argument is the second argument. I can make it explicit, but by default, it knows that the second argument in here is the dest file, and I'm going to call it data.zip because it's data. So data.zip. And it's downloading 20 megabytes. So that might take some time, but in the meantime, I can continue and talk about the kind of basics of spatial data and the tidyverse. So is anyone having issues getting up to that stage? Okay, and if you are, just give us a shout or ask your neighbor at some point. So this gives us a chance to get some data in and read it. So this is getting up to speed, and I'm doing this at the beginning because this is deliberately a practical session, and I want everyone to make sure that they've got the data at the outset. We can come back to the data at a later stage. If anyone's having issues getting it, that's no problem. And you can check that you have the right data. Again, it may take a while to download, but after I should say as well that I've saved the file in quite a distant, in a folder that was a bit long, so I changed the name of the folder, so it should just be in data. And once you've read it in, you should get something like this. And this is elevation data for the area surrounding Prague. And this point, I think we're somewhere inside this point in Průhonice. So that's basically some data to play around with. I'm not actually going to use this data to demonstrate the tidyverse, partly because the tidyverse doesn't really work with raster data at the moment, but that's something that's work in progress. But I think it's important, if we're going to do a practical example using real data, that I give you some real data at the beginning. So are there any questions on that? Okay, great. Okay, so are we ready to go? Well, hopefully there's some confusion, because as Roger said, confusion is good. So we've got some data, we've got a repo, and again, stuff's gonna start to go wrong. So let's just go back and recap some of the things that we know about spatial data. Probably number one, after downloading it and explaining to people where your data comes from, is being able to import it. And this is a good opportunity to talk about the book and some of the chapters that we've not mentioned yet. So there's a chapter on spatial data, on reading and writing it. So you can refer to this, and we cover quite a range of data formats and also places where you can get data. So these days, there's in fact a number of packages that provide you data directly, not just web services, but if you install these packages, you can start downloading data straight away from one of these sites. So that's just another detour that's worth mentioning while we're downloading it. But if you want to read more about various types of file formats, there's plenty of information there. So I don't need to talk about it. Yeah? Yes. So I've got an online version. So the easiest way to get to it is geocompa.github.io. Yeah.
When I get the download file, I try to do an unzip on it,
Mm-hmm.
and it said internal error in UN zip code. So instead I went back to download file and I used the argument mode equals WB, and that solved it.
Okay, that's really useful. Are you on Windows? Okay, so what I'll do here is say mode equals WB. Yeah, I've also had this thing, and I'll document that because it's useful for other people. So on Windows. Okay, thanks for that. So that's just, hopefully that's up there. So these slides and all the links are available in presentations, and they should be in here. I'm using a slightly different version of the slides because I made some last-minute changes, but you should be able to access the slides from there. So let's go back to the live demo. I've got some data, hopefully, called data.zip. It's not very useful in a zip file. So R not only is a great language for doing data processing, you can also do some basic kind of file manipulation stuff. So if I try and unzip data.zip, something's happened, and again I can run list.files, and instead of running it just on the base in my root directory, I can see that actually there's some stuff that's in a very far-flung place. And again, going back to the GIF of things breaking, this is really common. Has anyone had the experience where you download some data and it's just not in the right format, or it's not in a way that you'd expect it? This is a good example of that. Rather than just providing it in a single directory, it's miles away. So a way that you can get around that problem is you can rename the file. We're actually renaming the directory file.rename. And if I just go data, that's going to autocomplete. So I'm pressing tab, and it autocompletes to Prez geocomp data, which is a bit of a mouthful. And I'm going to put it into just data. Okay, so it's given me a message there saying, yeah, I've done that. And again, we can double check that we've got this. There's a function called list files. There's also a function called listers. And if I'm lucky, there'll be one called data. So I can see that I've got a directory called data, and I can even look inside this function, inside this directory now with list files. So list files, data. Bingo, and I've got some data. So that was hopefully not too fast, and it shows the type of workflow that I use when I'm getting started on a project. A colleague of mine said to me recently that it's better to build strong foundations than a castle made out of sand, and that's why I'm deliberately going quite slowly to get these strong foundations going at the moment. So apologies if this is a bit slow for you. But we are now in a position, hopefully, where we can read in some data. So Prague SF, and I've got a file in there called prague.geojson, and we can start doing stuff. The first thing that I always do when I get data, because I'm a geographer, I want to make a map, and I plot it, and I don't have all of it on there, but I can see I've got something. So that's a good starting point. We can get data in, and we can get data in from many, many different locations using the same strategy. And again, we've already covered this, but it's worth recapping the fact that Prague SF is a data frame, and this links to the tidyverse, and it's important in the context of the tidyverse because the tidyverse was built around data frames. So we've got a data frame, and this differs from the predecessor of the SF package because in the SP package, we didn't actually use data frames, we used something else. So I'm just going to put a pause on the Prague data set that we've just downloaded. We're going to come back to it, but to keep the 33% or roughly 30% of people who wanted to look at world countries data, I'm going to switch onto a new data set. And hopefully, you already have it on your computer. So I'm going to test this by typing world, and it gives me an error. So there is no object called world, so I need to do something to read it in. And this is a good point to make another, a good point in time to make another point is that if you're writing code, it's quite important to write it in the order that you want someone else to run the code. So even though I'm going to write library SP data next, I'm going to put it at the beginning because I want to make sure that all of the libraries are loaded at the same time. So again, you may not have this on your computer, but if you don't, now's a good time to install it. So I've got this new library, and this has given me a load of additional data sets, including this one called world. So we've provided the data in the world package. So has everyone got to that stage okay? So that's just loading the SP data library. And we're going to use this as a way to try and understand how SF objects differ from SP objects. So this is a useful technique if you're working with raster data because there's not 100% support for SF objects in raster yet. So as is a function that takes an object, and you can do this just by asking what do you want. It wants an object called world, and we're going to put it into a spatial class by typing as spatial. And then again, we can do the same thing on world SP and see what happens. And the reason, and you can look at the differences between these two objects if you want, but it's enough to say that SP does not work in the same way as SF. So if we go world SP, and I'm going to try and take, I'm not going to use the example in there, I'm going to slice it, which is the tidyverse way of saying subset. I'm going to try and take the first two countries in the world. That just isn't working. So this is illustrating that there has been a progression, hopefully, if this works, between SF objects and SP objects in the context of the tidyverse. So with SF, you can just use exactly the same code that you'd use on a normal data frame. So a lot of people learn R by doing non-spatial data analysis, by processing data frames. And a great thing from a teaching perspective is all those skills that you've learned processing data frames work the same. And if that, does that look a bit strange to anyone, that world and then a funny pipe and then a slice? Who's seen that before? Has anyone used that? Okay, so if this is new to you, can someone else tell me how I would do the same thing in base R? Pardon?
Slice, world, and then 1 to 2, square brackets, 1, 2,
Square brackets?
yeah, 1, 2,
Like that? No. So what you can do this, which also works. So this is something that I don't think Edsa talked about because he was also using pipes. What the pipe operator does is it takes this world object and it makes it the first argument in slice. So slice is a dplyr function, and the first object in any dplyr function is a data frame. So we've given it a data frame, and then this, although it's the first argument that you see, what's really happening, and there's a guy called John Mount, who I know Roger is a fan of, he says that dplyr code should be written like this. And in early versions of our book, we actually wrote this. So what this means is take the world pops up as the first argument here, and then it's executed. This is probably clearer code. So if you want to write your code in a very clear way, this might be the way forward. If you're a tidyverse guy, you're a purist, you'd say no because it's more concise. Yanis? At. So you mean at? Oh, the at command. Oh, head. Yeah, that's true. Yeah, so there is a command for doing this, and it's called head or hat. Sorry for the confusion. So this is a very good point. So basically, now we've got 3 ways of achieving the same result. Okay, yeah. And it's because it wants n. So so I wasn't thinking of head, but that's true. That's another way of achieving the same result. But what if I wanted to say, I'm going to make this harder and say 2 to 3? Well, don't give it away. So can someone tell me, without having, didn't hear what Yanis says, how you would achieve that same result in base R? Square brackets, okay, so tell me what to type here. Yeah, world. And then, okay, so this is basically 3 ways of achieving the same thing. And if you're doing 1 to 2, then yeah, if we're just doing 1 to 2, that's 4 ways of achieving the same thing. Okay, so sorry that's taking a lot of time, but I think it's important to realize that there's different ways of achieving the same thing, and the syntax of tidyverse is fundamentally different. In the tidyverse, everything has to be a function that begins with a data frame that can either be piped in from a previous command or is inserted directly into it. So that is how tidyverse works. And this is one package in the tidyverse called dplyr. So I should probably crack on because that was a lot of time talking about the tidyverse. So in the same way, the filter is the same as slice, but instead of taking a number, it takes a character or an object of the same class. So we can filter out the United Kingdom here, and this will return a single object of class SF. And again, in the base R equivalent, you're doing the same thing, but you're saying world, and then world name equals that. So there's two ways of doing the same thing. And there are many people who really get into this tidyverse, dplyr way of doing things. I think it's good for communication, but I can understand that it has advantages and disadvantages. So another advanced question: does anyone actually use Does anyone use dplyr in here, or how many people do? Okay, so almost half the audience. So this is quite an important distinction then. Can someone tell me what the result of this will be? Is that what happens if I ask, is that identical? Are these two things identical? Okay, so let's falsify that hypothesis. So we think it's going to be true, and let's test it. It's always the best way. So before executing all of it, I'm just going to check that both ones work. Yeah, that returns something, that returns something else, and I run them, and they're not the same. So what is going on here?
Does one print out something different than the other?
They print, I don't think it's a difference in the printing, actually. I think there's actually something more fundamental, or something inside the object itself. And this can catch you. This is a pitfall of using the tidyverse if you're not aware of it, and it's very subtle. So there's actually a bug report. There's an issue in the dplyr code which looks into this. So the answer is about row names. So if I just say, if I take this out, so I've got a row name of 144, and here, in fact, I'm going to make this simpler because this is just going to get a bit too complicated. So I'm going to say U1 equals this, and then create another object called U2, which is the tidyverse way, and then I can compare these two objects. Okay, and row names U1, row names U2. Okay, so they're totally different. Well, one of them's 144, which is the row number from the original table. dplyr destroys the original row names. And this is something that some people think is bad about dplyr. So that's another pitfall. Even after doing row.names, so even let's change the row name of U2, and I think we can assign this to 144. And then we can just check that that's changed. So these now have the same row names. I was hoping they were going to be the same, but I discovered that actually they're still different. Okay, so this is an advanced question now. What's the difference between these two objects? They've got the same row names, and they look the same. They should plot the same. So plot, can we see any differences in the plots? No, they're the same. So any ideas? And this is going into how R works and how SF was built. If Edza was in here, he would know. Anyone? Jakub?
I think it's because with tidyverse we've got a class of tuple.
I don't think that's right, but we can test it. No, it's kept the same class. So it's changed something in there. And I don't even know exactly what's going on under the hood here, but what I do know is that there's something called attributes, which is what you use to store all of the stuff that is outside of the main object. and they're different. I had a look at this last night, and the attributes of U1 and U2 are slightly different. So this is really going inside a kind of an SF object, and now I can say identical U1, U2, and finally they're the same thing. So it's just the attributes are different. I had a look in the attributes, and I was like, okay. And I couldn't find anything, but the dplyr changes the order in which they're arranged, basically. That's probably more than enough to say about this, but they're not exactly the same object. Okay, so that's filtering in any case. There's a more powerful way of subsetting by country name. So what we did here is we gave the complete name of the United Kingdom, and just to illustrate the danger of this, if you make a typo and call it United Kingdom, that doesn't return anything. So you have to be very, very specific when you use the filter command or when you use this double equals sign. So this is also something to say about the tidyverse. The tidy way of filtering by a character string is not really that tidy. You say filter and then grepl, which is a base R command, and then this is going to pull out any countries that have United in it. So this is a tidyverse way of filtering by a character string. So this is just a quick detour about regex. So just some challenges. The second one, can anyone tell me what this is going to produce? Bingo, yeah, you spotted it. So there's probably a lot of not deliberate errors, but that was a deliberate error. So when you're using these square brackets, you need to be very, very careful that you have the comma in the right place. So that's a danger with base R subsetting, that you need to have commas that respect the dimensionality of your object. Data frame is two-dimensional object, so if I put a comma there, it would be the same result, roughly speaking. Okay. And can anyone tell me the output of this one? Just grepl on its own? Yeah, the third one that starts with G. Good guess. It's not the names. It's something else. It returns an object. That's true. Almost. Exactly, yeah. Ones and zeros is exactly what it returns. And the best way to test this is, if you want to cheat, then that's great, because this is basically ones and zeros. It's trues and falses. So this just shows how the function grepl works. In both filter and base R, you're giving ones and zeros to that. If you want to turn the ones and zeros into indices, so let's create a selection object called cell. So we can say class of the selection. It's a logical, which means objects, which means that it's ones and zeros. If we want to make it integer, all you do is you use the which command, which says which ones of those are true. So you just say which cell. And then I can run that, and it says the 5th country, the 85th, and the 144th, which is the United Kingdom, have United in it. Okay, I'm not going to spend a lot of time on these other ones, but the point is that regex is a really powerful way of interacting with character strings. So you can use this thing called regex. There's special search things in there that identify things like the beginning of words. So that's going to find me all countries that begin with a U. So the hat symbol there finds anything beginning with a U. So Uruguay would come out of that. And I encourage you to try this on your own computers if you've got time. And this one, if that one was the beginning of the word, this one is the word ending. So anything that ends in an M. And then a final one that I will ask people, can anyone tell me what this is going to return? And this is just basic regex. It's not really spatial stuff, but it's good context. Yeah, exactly. Although it's anything that contains the string anywhere that UN. So this means or. So it's a really quick way of saying, if I want a list of countries that have certain characteristics, I can do that. So again, hopefully this is a really useful tool for you that you can use when you're looking at data. Okay, so moving on to stuff that's probably more commonly used. Well, I think regex is very commonly useful. I've used it loads in my research. There's aggregation, and Edza mentioned this, but it's worth reinforcing it. You can do aggregation in the tidyverse. Involves more steps than in baseR. So in baseR, you just use the aggregate function. But in the tidyverse, the first thing you do is you've got to group it by something, and then that group object, you've got to summarize it, and then you've got the results. You have to say some aggregating function, and in this case, we've got the sum of the population. And you can add additional arguments in there, such as remove values that don't contain anything. And I think this is one case where the baseR is definitely faster, is more concise anyway. So the way that you would do that, I don't know if I've got it on here, you just use aggregate. So again, you can say world cont. Okay, so that's how you do it in the baseR. And you can see the 6 continents. We've compressed all of the countries in the world to just 6 units, and we've summed up all of their countries. So if we just say summary of world cont, we can see what's in there. And you can see the numbers of populations are pretty big because these are continents we're talking about. So I think in a way it's problematic because it's harder to remember 2 ways of doing things. And I'm not going to make any judgment about which one is better. It's just good to know that if you like this syntax, then you can use it. But also the baseR aggregation method is also really concise in this case. So you're saying take the population variable and aggregate it. This little tilde means aggregate by continent, and the data is the world. So that's a really nice, concise syntax, but it may not be 100% intuitive. It took me a long time to learn that syntax. So again, you've got 2 ways of doing them, but I think it's probably best to decide which one you like and stick with it. One thing I would say is that the baseR, especially with simple features, is probably more reliable. So you can do more things with baseR than you can do with tidyverse because there's not 100% support yet for simple features in the tidyverse. So you can also do spatial subsetting in the tidyverse, but it's going to be quite a lot more concise in the baseR way of doing things. So what we're doing here, and this is just showing the kind of dplyr pipeline, we're taking another object called London, which is also in the spdata library, and then you're transforming it into the right CRS. You're creating a buffer that's going to be in meters, and then you're transforming it back. So you can do a whole series of steps in the correct order and then spit out the result. And that is probably not going to run particularly fast because that's the same as having nested function calls inside each other, but it allows you to have a linear workflow where you're doing one thing and then the next thing and then the next thing. So feel free to enter that code. And then we're actually going to use the base R subsetting to subset countries in the world that are close to London, just to illustrate the point here. So this is a good example of combining tidyverse and base R. And I do this quite a lot. I combine the two things because that's just how I work. And again, there's many different ways of doing this work. But this is just an example of saying, tell me all of the countries that are within 500-kilometer radius of London. And you can see it's got the right result here, but what's going on out here? It's got something that's associated with these countries that's miles away. So that is another issue that you can get. And I'm not going to ask this, but I'll just explain. This is because the object type of these geometry is a multi-polygon. So each object can have multiple polygons in it. And I can just demonstrate that in the code by saying st geometry type. And you can see they're all multi-polygons. So what's happened is that we have successfully selected France, but France is also a country out here in Latin America that's miles away. So again, how do you overcome that problem? And I should just say, this is really worth emphasizing. This is really clever because it shows that SF allows you to take one spatial object and use it inside the square brackets of another spatial object to do subsetting. So subsetting is more concise using base R functions. And again, this explains what I've just done. And you can see here that France has actually got 3 polygons associated with it. And we're just creating that function there. And that's in the slides if anyone's interested. So if you want to remove those objects that are miles away, you can convert it into just a pure polygon object. And then you can filter it. And then this final line shows that if you want to be a tidyverse purist, you can use tidyverse. You can use tidyverse to do spatial subsetting, but it's going to look a little bit clunky. So you're going to say st intersects. You're taking the previous object, and then you're saying those that intersect with the London buffer, and you have to specify the type of the result so that it's not a sparse. List object. So that's quite complicated. If you're doing just spatial subsetting, which is subsetting one spatial object by another spatial object, you're basically probably better off just doing this. Okay, so that's another pitfall of using spatial data in the tidyverse. I've already covered row names. Duplicate column names is another problem. So if you have 2 objects with the same column name and then you try to combine them, it's going to fail, or you try and do some operation. And this is actually, again, an issue that's on GitHub that people are working on, but they've been working on these problems for quite some time. And the final one that I'm going to demonstrate is just a really quick one. So I can say W1 is, and because this is about the tidyverse, I'm going to do the tidyverse way of doing it. So slice the world and just take the first row, W2, and take the second row, and you combine these two together with rbind, W1 and W2, but as far as I remember, bind rows in dplyr gives you an error. So that is actually a bug. That's a bug in dplyr that Hadley Wickham and people are working on resolving this in the long term. So that's just a few pitfalls, but overall, for like 90% of things that you can do, tidyverse works. Some people like the syntax, some people don't like the syntax, but I just wanted to present it as a way of doing spatial data analysis. And all of these things that we're producing, it doesn't matter whether you produce your objects in the tidyverse or using BaseR, the visualization code is going to be the same. So this is just an example of leaflet. I'm not going to go into that because I want to get on with the exercises. Or you can use tmap for the visualization, which we were talking about yesterday. So that's tmap methods. If you want to reproduce those examples, you've got everything you need. You've got the slides, which are online here, I think, that you can find them. You've got the data loaded in, but now it's time to actually do some practical exercises. One thing that I've noticed is that we've spent most of the time working on our own. I've learned a lot of R through helping other people or working with other people, and other people helping me when I ask questions. So I'm actually going to get you to get into groups of 2 or 4. But first, I'm going to ask people, this is based on the poll that I did, to say roughly which exercises are you most interested in solving. So this is not all of A is easy and all of B is intermediate and all of C is advanced, but I want people to roughly decide on which problem they want to solve. So A is about consolidating tidyverse. So if you just want to learn about tidyverse functions and how to do attribute operations of the type that we were doing on the world object, I suggest that that's A, and that's working through the exercises in our book. B is building on Ed's example yesterday, where he gave you a data set that Tim created for the MapView package, and I've got some more kind of follow-on exercises that you could use the tidyverse to solve. I'm not going to complain if you use other methods to solve it. So stuff like, which was the earliest founded brewery? I bet Tim knows what the oldest brewery in Franconia is. I was really surprised how far back in time they go. It's like thousands of years old, these breweries. Which one has the longest name? That's the challenge. So these ones are kind of intermediate data processing. It's mostly focused on vector data. And then you've got a more advanced one, which is which breweries, so find the trail that's best for alcoholics, which trail goes past most breweries. And you can use these tidyverse functions or BaseR to answer those questions. And then finally, building on the sea level rise example that we created for the book, which I've actually put into a slightly nicer format. Hopefully it's here. So all of this is reproducible, and it's all based on data that you've already downloaded. I've got some questions. So I've taken 2 data sets, and I've checked that they're basically the same thing after aggregating them, so they're at the same spatial scale. And then the end result is an estimate of the area in a town. This is Szczecin in Poland that's going to get flooded if there's 10 meters of sea level rise. And that may not be true for the next 10 years, but it might be true in the next 100, 200, 500 years. It's quite likely that we'll see some fairly high levels of sea level rise. And I've also, at the end, created an example of Prague. So if anyone wants to use this Prague data set and quite high resolution digital elevation model, the problem is that Prague isn't going to get flooded, probably. It's at 200 meters. But you have to create a scenario in which you imagine, and this is the great thing about modeling, you can imagine things that maybe aren't too realistic. So those are the options anyway. You've got one that's about consolidating what I've talked about if you're interested in the tidyverse. You've got another one that builds on the example from yesterday if you enjoyed that. Or you've got a third one that's about sea level rise. And I've also got some more advanced ones. So the first one within C is basically just to reproduce on your own computer what I've already done, but find out the percentage of this area, this kind of administrative zone that's going to be flooded under 20 meters, and then what percentage of Prague area will be flooded under 200 meters. I don't know, I haven't done this yet. and the percentage of any other town in the world, because the code that I've written can work anywhere in the world, that would be flooded by any other sea level rise. And if you want to, you can look at the science on sea level rise, not into the next 100 years, but in the next 500, next 1,000, next 10,000 years, and I bet you'll be surprised how much sea level is going to rise. So I'm not going to dictate what value to change, but you can really pick a city of your choice and estimate how much is going to get flooded under a scenario. So I've said 10 meters, you could say 5 meters, including a storm surge, or you could say this is going to be really apocalyptic, we're going to get 100 meters of sea level rise, which I think is probably unrealistic, but for the purposes of learning, hopefully it'll be interesting. So those are the practicals. Can I just get a rough show of hands? If you want to, and you don't have to work in a group, so if you want to work in a group, is there anyone who wants to do A, which is the kind of consolidation stuff? So put your hand up if you're interested in that. So you've got a few people there. And B is anyone wants to build on the breweries, find out the oldest brewery in Franconia. Kind of interested in that. Okay, so there's a good distribution. And then if you're interested in doing the sea level rise, put your hands up. Who's interested in that? So actually, we've got quite a good mix, despite the thing. So basically, I'm going to ask people to get into groups and kind of move around a bit. So I guess what I should do is decide places. So maybe if people who are interested in A come to that side, there's loads of space at the back. So if B wants to go to that corner, and then if people interested in C want to kind of accumulate here, then get into groups of 2 or 3 and actually talk to each other and do this as a group exercise. That's the plan for the practical. Okay, everyone. So I think we're gonna break for lunch pretty soon. But I just wanted to make a few comments. Number 1 was about generalizing code and also reproducing code. So you probably noticed, if you did the sea level rise example, I had a lot of commented code in here because I didn't want it to take ages on your computer. I wanted to do the hard work of downloading it. And you can see that I use this elevator package. So this is just a way of me saying I've used elevator to get it. And the wider point is that there's loads of packages now that get data from a specific part of the world, and spatial data processing is moving in this direction towards cloud services. Elevator isn't a particularly great package because the default source it uses is MapZen, which is a company that no longer exists. So you have to set the SRC to something that's different. But the point is, the benefit of using a cloud service is that you can get anywhere in the world. There's probably, there's no way that I can get a very high resolution image of elevation on my laptop and give it away, but I can take just a little chunk of that data. And this is an example of a cloud service being called from R. And increasingly, things are being done like this. This is exactly what the kind of thing that Edza was talking about with Google Cloud Earth Engine. I've never used Google Earth Engine, but you can get data from a specific part of the world by asking this service to give it to you. Google Earth Engine, if Edza says it's a very powerful and flexible way of doing it, I believe him, but there's other services that will give you climate data, elevation data, soil data, and I'm led to believe that the OpenGeoHub itself is aiming to provide services to get data to you. And in the last 5 minutes, I've just said, okay, let's see if we can get elevation for London. I don't know if it's any good, but you can see that if I make it go to a different, you can see you've roughly got the elevation from London, for the UK. And the reason why it hasn't just done London, it's done a massive area, is because I set the zoom level. So this is a great package. So even though it's got limitations, it's very useful because depending on what spatial scale you're looking at, you can set the zoom level and download data. If I were to set that at 18, it would probably never download. I could probably go to 6 and I would get a slightly higher resolution image. And the general point there is when you're doing data analysis, it's always better to get low resolution, approximate data, run your model, and then increase the resolution and the accuracy rather than trying to go in at the highest resolution at the beginning. At least we can get some kind of model going. So again, I've updated this data set, and it's taking longer to load. So that's the problem with high-resolution data. It takes longer to load, especially when you're using interactive mapping like this. So you can just see there that they're the two zoom arguments in elevation. And if anyone in here wants to go on and do some sea level research for a particular area of the world, now you know that you can get elevation data for it. You can get even better elevation data from NASA. So NASA's got a really awesome web portal. So if you want to get really high resolution data that you can cite, I'd recommend doing it from here, but it doesn't have the same flexibility as the elevator package. So I think I'm going to end it there. Can I get some feedback? Did anyone, I know that there were quite a few people looking at the tidyverse stuff, and some people were looking at the breweries. Can anyone tell us what the oldest brewery is in Franconia? Tim? Okay. It's So yeah, it was. I saw one that was 1400, and then finally, can anyone tell us a result from a sea level rise? I know you've only had 20 minutes to do this, but did anyone get an interesting result for Prague or Szczecin? 60%. Okay, right. Great. Okay, so hopefully that was a useful exercise. Everyone's done really well. Are there any final questions? Okay, no problem. So you can come and talk to me after anyway. It's lunchtime now, and we're going to come back here in about an hour's time, and we're going to look at our bridges to GIS software, which really opens up a whole new range of functionality. So thanks everyone for being good at listening and for doing the practical work, and see you after lunch. Thank you.